day! I'm Dr. T and welcome to my office. So in a previous video I talked about chemical equations, the way we write out a reaction to describe what's going on. And in that I mentioned the coefficients. These were the numbers that appear before the chemical formulas and describe the ratio of each chemical formula's involvement in the reaction. Now those ratios are in either individual atoms or formulas, or they are in moles of those. And moles are a unit of measurement. It's a counting unit. So kind of like a dozen, but instead of being 12 of a thing, it's 6.022 times 10 to the 23rd of a thing, which is a really large amount, except for the fact that atoms and molecules are really, really tiny. So, you know, they kind of cancel each other out. So for reference, something like a small glass of water, really more like a shot glass of water, is about a mole of water. Around 50 grams of iron, or 55 grams of iron, is a mole of iron, which is, shall we say, not much. It's a big nail. I mean, a really big nail, but it's still a nail kind of sized. So when we're dealing with these equations, we're going to be looking at them, and that's going to be telling us, you know, individual atoms and the ratios of those, or in moles, which once again, counting unit, just like you measure eggs in dozens, you can measure atoms in moles. Now with this we can actually use a lot of useful techniques. We can look at those molecular weights. Conveniently, we can, use this mole. The reason it's such a weird big number is that allows us to convert from those relative to hydrogen, or actually relative to the mass of a proton in carbon units, the Daltons that I talked about in earlier videos, and interchange those for grams. And thus we can take our block of whatever, weigh it, and we can know how many moles of whatever that stuff is in there, if of course we're able to look at a periodic table and look at the atomic masses and add them up, and okay, there's the mass for a mole of this thing. Well, how much does it weigh? Hey, we can convert pretty easily. Alternatively, there are other ways of doing that. If you know the molarity of a solution, well, that contains moles in liters, boom, you've got moles. If it's a gas, there's the ideal gas law, which allows you to calculate moles of gas if you know the pressure, volume, temperature of your gas. But in either way, we can get our reactants or our products, we can convert those into moles, and then we can figure out quite a few useful things. So if I've got a chemical reaction, I know I have a certain amount of product that I want to make, therefore I can figure out how much of each reactant I need to put in. This is called stoichiometry. And with stoichiometry I can actually go a couple other steps. I can say, hey, if I've got two reactants, I know how much of each one I have, who's going to get used up first, what we call the limiting reagent, because that's going to limit the reaction, it's going to run out, and which one's in excess. Obviously, depending on what I'm doing, I might want to make sure that one of them is the limiting reagent, like the really expensive one. And therefore, I use up the really expensive stuff and I have leftover cheap stuff that I don't mind wasting because it's cheap stuff. And this is going to allow us to predict, how much chemical you produce with how much reagents. The amount of chemical you produce, that's called your theoretical yield. It's called theoretical yield because that's how much you calculate, and in theory you should get. The actual yield is what you actually get. It's always going to be a little bit lower, hopefully not too awful much lower, but of course depends on, how well your reaction ran, what exactly your reaction was. Some of them are finickier than others, and of course, how careful you were. But hopefully it's a nice large amount. So with that really brief introduction to stoichiometry, have a wonderful day, and I will see you in later videos.